Now another variation of this can be, you have been told that there is an array. There's an array of the length n, okay, and elements are in the range of 1 to n minus 1. Okay, there's an array of the length n, and the elements are in the range of 1 to n minus 1. Okay, it means that one element is repeated. One element is repeated, right? Then only you can have like array of the size n and have element from 1 to n minus 1. So if it is a array of size n, it means one element will be repeated. You have to find which one is the repeated element. How will you solve this question? Simple one, right? Can you quickly tell me how do we solve this question? There is an array of size n. So for example, suppose n is equal to 5, okay, and the elements should only range from the 1 to 4, right? So the array could be like this: 1, then 4, 2, 3. So suppose here the 4 is repeating. Now, if this is a question, you have to tell me like how do you find that which element is repeating? How do we solve this question? Jahir, Paritosh. Okay, tell me how do we solve this question? If suppose George doesn't box out here, can you think of anything else that we can solve it here?
So I will sort the array first.
You will sort the array first. Very nice.
Then I will check from if I will start from 0 index. Then I will check if ai plus 1 is equal to ai. Then I will return ai.
Okay, so basically, what will the time complexity in that case, Jahir? It will be n log n, right?
N log n merge sorted.
Perfect. Everybody agrees to this solution. This will work because if you merge sort it, it will be n log n, and then if you check two consecutive elements, you can linearly figure it out that if any element is repeating or not, right? So that is n log n. Cool. Anything better approach? Anything better than this? Anything better than this? So let's try to extend this question a little. I'll come back to the George here, but suppose let's try to extend this question. Let's try to make this a little more complex. So I have been given an array, okay, and the array size is n. Elements are lying between 0 to n minus 1, suppose. So element is the range of 0 to the n minus 1. Okay. What you need to do is that now any element can appear any number of times. There is no limit on it now. Let's make it more generic. Any element can appear any number of times, but the only restriction is that elements can only range between 0 to n minus 1. Size of the array is n. Okay, this is also fixed. You have to tell which element appeared maximum number of times. Example, suppose n is equals to 5 or n is equal to 7. So the numbers will lie between 0 to 6. Okay, so my array is like this right now. So suppose it is 3, then 5, then 6, then 1, then 3, then 5, and then say 3 again. Okay, so here the 5 is appearing twice, 3 is appearing thrice. So the number which appeared maximum number of times is 3. So answer is 3. Okay, can you try to solve this question?
I have this an approach. I have an approach, but there's one concept which has not been covered. I mean, I can use a hash map here.
No, so hash map. So let's try to avoid something which we have not studied so far. Yeah, definitely hash map you can use. What you can do, you can iterate through each of that. You can store the key, and then you can increase the counter in the value, and then once it is done, then you can find out which element has appeared the maximum number of times. So that is fine. That will work. But let's not use hash map as of now, because again, even if you know hash map is not an optimized solution here, because hash map will cause extra space. I don't want you to use extra space in this case. How do we solve in that case? Anybody else? Jahir?
Sir, like previous one, I just sort the array first.
Okay.
Then what I will make, I will just make a variable like in max frequency, which will be like 0. Then I start counting the frequency of the number. If that frequency is greater than in max, then I will return that number.
Very nice, very nice. Do you guys agree with this? Jahir?
Yes.
The one algorithm that Jahir suggested is very nice. What is we do is that we sort it. So it will take n log n time. Okay. And then we iterate, and keep a variable which looks at the frequency elements finally return. Cool. So what is the time complexity of this algorithm, which right now Jahir has explained? What can be the time complexity of this?
N log n.
Cool. So now it is fine. I'm okay, but I want you to improve it further. Can we further improve this algorithm? I want to do this and say, oh, and without. So now I'm going to tell you a concept which is a very strong concept, right? And this will help you to solve many problems very simply, very simply. So please note this concept somewhere. It's a little confusing, but if you understand it clearly, it is a very strong concept. This will help you in a situation when you have to store the two kind of information in the same array. Okay? When you have to store two kind of information in the same array, with this you can do it. You don't have to use a two-dimensional array. In a single dimensional array, you can store the two kind of concepts. So what I do is, so I have been told that the n is equal to 7 here, and the elements are lying in the range of 0 to 6. After like which element appeared maximum number of times. Now suppose the question becomes more generic, in which not only that, but I have to tell what is the frequency of each of the element, right? So if the question becomes like this, that what is the frequency of each of the element, in that case normally if you think, you feel like I have to have another data structure to store the frequency of each of the elements, right? Otherwise it is not possible, right? If I have to tell what is the frequency of each of the elements, so frequency of 3 is 3, frequency of 1 is 1, frequency of 5 is 2, frequency of 6 is 1, frequency of 2 is 0, frequency of 4 is 0, right? So if I have to tell the frequency of each of the element, I definitely need some another data structure to store that information, some key value kind of data structure. So normally, naturally comes like map is the most fit in data structure for that. Make sense? Can you think of anything that I can tell the frequency of all the element without using any other data structure? Can you think of a way? If you have to tell that what is the frequency of each of the element to depict that, to store that information, can you think of a way in which you can do it without any using any space? Cool. So let's go and see how do we do it. So what we do is that first of all, you go to each of the element. Okay, you go to each of the element. So I went to the first element 3. I went to the first one, which is 3. So once I go to the first element, I go to the 3 index, third index. Okay, and there add 7. So what happens, this will convert this array into this array. So 0 1 2 3, and I make it 1 plus. Okay, what I do 3. Okay, and basically when I go to the first element, let's try to do a modulus of 7 first. So if I do a modulus of 7, uh, it will come out as 3 itself. So I went to the third index, and then when I went to the third index, I add 7 to it, so the array became equal to this. Okay, now I came to the fifth. Now again 5, I do a second element, I do a modulus of 7. Okay, so I go to the fifth index, and there add 7. So fifth index is what? 0 1 2 3 4 5. So I get 5 plus 7. So I just copy this. Similarly, I come to the third element. So I did 6 ampersand 7. Okay, I went to the sixth index. There I go and add 7, and it becomes 7. So far so good, guys. Is it clear so far? We'll see that what it will turn out, but so far logic looks fine. Whatever that we have written, how we are adding the elements to the array. Is it okay? Is it clear, guys?
Yes.
Yeah. Perfect. So now that I'm getting is 8, right? Because the next element, the fourth element is 8, so it becomes 8 modulus 7, and this will come as 1. So I come as the 1th index. So there add 7. So what happens is that in this array, we copy this and I made it plus 7. Right. Similarly, the next element that I have is 3. So 3 modulus 7, and then again it is 3 itself. So this is basically third index. So again I went to the third. So this was my previous setting. So the third is 0, 1, 2, 3. So it becomes 7 plus 7. Okay. And then the next one is 5 plus 7, which is 12 divided by 7%, which is equal to fifth index. There and 7. So if I add the fifth index, the fifth index is 5 plus 7 already, so I add a 7 to this now. Okay. And the last one is 10. 10 7%, 7, and is equal to third index. So this now comes out. So third index is this, so I add plus 7 here again. Okay, so this is what the final array comes out to be. Okay, so my resultant array is now this one. Okay. Now this array holds two kind of information. With this, I can also tell you that how many times the each of the element has occurred. Like this array will start showing the frequency of each of the element, and the same array can also show you that what was the initial condition of the array. How do we do it? How do we do it? So if we divide each element by 7, if you divide each of the element of this array by 7 now, okay, so what it will do, it will, so the 3 when divided by 7 it will become 0, the 5 plus 7 when divided by 7 it becomes 1, 1 plus 6 when divided by 7 becomes equals to 0, 1 plus 7 plus 7 when divided, 1 plus 7 plus 7 plus 7 which is equal to 22, when 22 when divided by 7 it becomes equals to 3, okay, 3 when divided by 7 it becomes equals to 0, 5 plus 7 plus 7 it means like 19, right? 19 when divided by 7 it comes out as 2, and 3 plus 7 divided by 7 is equal to 1. Okay, so what it means that now when we divide each of the element by 7, I get the frequency of each of the index. So 0 is appearing 0 times, 1 is appearing 1 time, 2 is appearing 0 times, 3 is appearing 3 times, 4 is appearing 0 times, 5 is appearing 2 times, and 6 is appearing 1 time. So this gives me the frequency of each index, right? And in the same array, if I take a ampersand, we take ampersand, we get the original array. So if I take an ampersand by the 7, what it will do, 3 ampersand 3 will do 3, 5 plus 7 ampersand will give me 5, 6 ampersand will give me 6, 1 plus 7 plus 7 plus 7 ampersand will give me the 1, 3 will give me 3, 5 plus 7 will give me 5, and 3 plus 7 will give me 3. So if we bring the array to this state, just dividing each of the element will give me the frequency, and just ampersanding each of the element will give me the original array. So we are showing two kind of information in the same array using alerts, ampersand and division mathematical operator. And with this, without any using extra space in a linear time complexity, I can tell that what is the complexity of, what is the number of frequency of each of the element. Like 0 is appearing 0 times, 1 is appearing 1, 2 is appearing 2, 3 is appearing 3 times, 4 is appearing 0 times, 5 is appearing 2 times, and 6 is appearing only 1 time. So this is a very strong concept. In this, using the same array, I can hold two kind of information. I can also hold the information about the frequency. I can also hold the information about the original state of the array. Right. So each of the index value indicates how many times that index has appeared. So index 0 value 0, it means 0 has appeared 0 times in this array, right? So 0 has appeared 0 times in this array. 1 is showing 1, so 1 has appeared 1 time. So the 1 has appeared 1 time, right? Now for 2 it is taking 0, so it means 2 has not appeared, so there is no 2 in this array. Then 3 is showing 3 times, it means 3 must be 3 times. So 3 1, 3 2, and 3. So 3 has appeared 3 times, right? Similarly, so basically the value at each of the index is indicating how many times that index has appeared, how many times that index has appeared, right? So when we do this approach, in the same array, we are able to store two kind of information. One, so this basically this array has two information. If you divide, you get another information. If you do ampersand, you get another information. Dividing will give you the frequency, and doing ampersand, doing a modulus will give you the original state of the array, what the array was initially.
What's the name of this approach?
There is no name as such, man. This, but I really find this very helpful. Mostly in the competitive coding, when you actually are striving for a space and you don't have enough space in that case, and you want to solve it fast. Using these two operators really helps. So you should know how to use intelligently this modulus operator. It's a very strong operator. In multiple cases, you go and use it. So we'll see in the further in the stack data structure also, when we are defining the stack and the queue. We will be using this modulus data structure to optimize few things. Okay.